Hey guys, and welcome back to 2 Minute Coder. So today we're doing LeetCode problem 15, which is threesome. So if you guys haven't checked out my previous videos on twosome, on both iterations of twosome, then I'll link that in the description below for you guys to check out because we are going to be using some of that logic in this solution today. So let's get into the question. So given an integer array nums, return all triplets such that the triplets are distinct, the triplet adds up to 0, and in our entire solution set there must be no duplicate triplets. So what that means here is this is a triplet, which is just an integer array. Then in our solution set, which is a list of integer arrays, there cannot be any duplicates. So you can see in this first one, -1, 0, 1, which is -1, 0, 1. There cannot be another 0, 1, -1 because then that would be a duplicate triplet. Okay, so the way we're going to solve this is iterating through nums. And for each iteration, we're going to do a twosome solution via 2 pointers. Okay, so what that means is when iterating through nums at index I is going to be our first value in the triplet. And then to find the other two values in the triplet, we're going to be doing a 2-pointer solution for the remaining values in nums. Okay, so if you guys remember, the first thing that we do for a 2-pointer solution for twosome is to sort the array. Okay, now let's initialize our solution set. So we can see that it's going to be a list of integers. So let's use a linked list of integer. Let's call it solution equals new linked list of list integer. All right. So now for the first loop where we iterate through nums. So for int I is equal to 0 and I less than nums.length minus 2, I increments. So we're doing -2 because we know that we're going to be putting 2 pointers at the remaining 2 values. So if we have this as -1, as we usually do, there's going to be an index out of bounds error. Okay, so now to find a starting point. All right, basically finding the first value in our triplet. So for if I is equal to 0, or if I is greater than 0 and nums at index I is not equal to nums to its previous, right? Because if I is equal to 0, then we know that we don't have any, there's no chance of having duplicate values because there's nothing that we've computed before, right? And this is there to check that we aren't landing on another starting point, because then the remaining 2 values will be the same. So if you imagine that this 0 was also a -1 and this 2 was a 0, then it would compute a duplicate triplet. Okay, Okay, so now that we found a starting point, we need to initialize our pointers. So our left pointer is going to equal to I plus 1. Our right pointer is going to equal to nums.length minus 1. Right, now to do the two-pointer approach, while our left pointer is less than our right pointer, we need to initialize, we need to initialize pointers and target. So like pointer values and target. So our target is going to equal to 0 minus nums at I, which is our base, so 0 minus base, and our left number is going to equal to nums at index of that left pointer. Similarly, right num will be nums at index right pointer. Okay, so if left num plus right num is equal to the target, we know that we found a triplet. So we will initialize a new integer array. So array list of integer, call it mini solution equals new array list. Okay, and to this mini solution, we will add our base, which is the value at nums of I. We will also add, our left num, and we will also add our right num, and then this mini solution will be added to our main solution. Okay, so if left num plus right num is equal to target, then we do this. Now what if left num plus right num is less than our target? Then we know to increment our left pointer. Right, this is what we did in our two-sum, and else we will decrement our right pointer. Okay, but we need to add something here because we have to make sure that our triplets are not duplicates, right? So we need to make sure that our new pointer values should not be the same as the previous iteration. Okay, so while left pointer is less than right pointer, and our left num is equal to nums at left pointer plus 1, so the next pointer that I will land on will keep on incrementing, and similarly while left pointer is greater than right pointer and right num is equal to nums at right pointer minus 1, we will keep on decrementing, right? Because we do not want this statement, right? We don't want it to be equal. So when it is equal, we're going to keep on incrementing and decrementing. All right, and if none of these while loops execute, which means that our next pointer values are going to be different than the last iteration, we can just do a normal increment, right? And then we return our solution outside of this for loop, so return solution. Let's submit that. Line 5 error. Oops. Just missed a bracket there. Yep. It's a little bit slow because of all of the comments, I think, but basically the time complexity for this is, as you can see, we're doing a nested loop, so it's n squared, and our space complexity, it can vary because although we aren't holding any, it can either be linear time or constant time depending on the sorting method, because some sorting methods, they have a linear time space complexity, so depending on that. Okay, so this was LeetCode problem 15. Hope you guys enjoyed, and subscribe for more.